Hello everyone, hope you're doing good. Welcome to DC TechNet. DC TechNet is your own channel, so do like, share and subscribe. It will not take more than 2 seconds to like, share and subscribe the channel. So we'll continue our deep dive on our DHCP or Dynamic Host Configuration Protocol, and we have already seen the DORA process in our earlier sessions, how the client discovers the DHCP server, how the DHCP server offers the client the IP configuration and the request and the acknowledgement. So in today's session, we'll touch base what is automatic private IP address, that is APIPA, and we'll also touch base the thought process behind APIPA or automatic private IP address, which is the integral part of DHCP. So these are the two concepts that we are going to understand today. So let's move ahead. So we had a question in our earlier session, and the question was, what will happen if the DHCP client is not able to discover the DHCP server? So this was the question. What will happen if the DHCP client is not able to discover the DHCP server? So let's see what we have. So definitely the client will not get the IP configuration because it's not able to find or discover the DHCP server. But a state of APIPA will arise over here if the DHCP client is not able to discover the DHCP server. So what is APIPA? So APIPA stands for Automatic Private IP Address. So whenever the DHCP client is not able to discover the DHCP server, it will automatically assign an IP address to itself from this range, and this is a specified range 169.254.0.1 to 169.254.255.254. So if the discovery fails, the client will say pull up any IP address from this range and assign it to itself. So this is a class B range, and if you run ipconfig, it will look somewhat like this. So it will pick up any IP. In this example, the client has picked up 169.254.6.2 and the mask is 255.255.0.0 as a class B default subnet mask. So next question, is this APIPA or automatic private IP address good or is bad, man? So if it's good or if it's bad, the main question remains why it's good or why it's bad. So we have to focus on why. So definitely the APIPA mechanism is good. So let's understand why the APIPA mechanism is good. Now we know that the discovery messages sent by the DHCP client are always broadcast. So it will be heard by everyone. It's not unicast, it's absolutely a broadcast message. So if the DHCP discovery fails for all the clients, there will be a broadcast storm on the network, which will create a network jam. So it will be a complete broadcast traffic on the network. So it will just jam the network. So there will be a bottleneck on the network. So the APIPA mechanism prevents this broadcast storm by assigning an IP configuration on a temporary basis. So the DHCP client will say automatically assign an IP address to itself, and it will just stop this broadcast storm for some time. But even if the DHCP client say gets an APIPA IP, it will, after every 5 minutes, it will try to discover the DHCP server. So it will definitely broadcast the message, the DHCP discovery messages, every 5 minutes. But it will definitely say control the broadcast storm. So this is one of, say, this is the advantage or good thing about APIPA, or automatic private IP address. So let's see in the pictorial form now. So we have DHCP clients, DHCP server. So for some reason DHCP server is unavailable. It can be network, server down, or it can be any other reason. So the DHCP clients will start broadcasting or sending DHCP discovery messages on the network, and this discovery message will heard by every active, say, device on the network. So to control this DHCP broadcast messages, Microsoft introduced the concept of APIPA, or automatic private IP address, in their Microsoft Windows operating system. So this concept of APIPA is only applicable to Windows operating system. So let's summarize what we have seen today. So we have seen what is APIPA, the entire thought process behind APIPA. So the thought process is to avoid or to minimize the broadcast storms on the network if the DHCP server is not reachable by the DHCP clients. And the third most important thing is, this is applicable only to Microsoft Windows operating systems. It's not applicable to any other operating system. It can be client operating system or server. So hope you have enjoyed today's session. You have learned something new. So thanks for joining today's session, and if you feel that this channel is helping you to learn anything new, do like, share and subscribe, and do not forget to comment on, say, any session or any video. And if you want something new, please comment. We would be very happy to create the content. So thanks again for joining today's session, and enjoy your day.